Hello everyone. In this video I'm going to show you how to set up and solve some logarithmic and exponential equations using rules of logs and inverse functions. So for number 1 here we have, under certain circumstances, a rumor spreads according to this function, p of t, where p of t is the percentage of the population in decimal form that has heard that has heard the rumor at time t, and t is time and days since the rumor began to spread. So for the part A and part B, we're just going to plug a couple of values into the p function to kind of get a feel for how it works. And then for part C, we're going to do the actual solving. So for part A here, I am just plugging 0 into the function for t. So I'm going to do p of 0 equals 1 over 1 plus 4 e to the negative 0. And then negative 0, of course, is just 0. And remember, anything raised to the 0 is 1, with the possible exception of 0 raised to the 0, which you'll hopefully learn about sometime in calculus class. So this is 1/5, which I believe is 0.2. You could also put this into a calculator if you wanted to. So 0.2, this means 20% of the population. So interpreting it in terms of the real-world application, 20% of people have heard this rumor. Basically, 20% of the people were there when the rumor was first announced in whatever form, I guess. What percentage of the population have heard the rumor after 1 day? So for part B, we're going to plug in, let's see, they said t was in days, right? Yeah, t is time in days. So we're going to plug in 1 for t. So if it was hours, we might have to make a change here, but since it's days, we can just plug in 1. So e to the negative 1. Okay, and so for this, I'm going to need to put this in my calculator. So here is my calculator. So I'm going to do 1 divide by, now I'm going to need parentheses because the calculator doesn't have a neat little fraction setup. Actually, there is a way to do it on this calculator with the n over d button. But most calculators don't have that. So I'm going to put parentheses around the bottom to protect it. And then this is 4 times, and where's my E button? Let's see. E is, second E. Okay, there we go. And then I'm putting negative 1 in the exponent there, and I'm going to come back down from the exponent and close parentheses. And let's see if that does it. Yes, so 0.405 if I round to 3 digits. So that is 40.5% of the population. So it looks like it roughly doubled after a day. All right, so then for my part C, I want to know, when has 95% of the population heard the rumor? So obviously I think it's going to take longer than 1 day, right? And it looks like it roughly doubled after 1 day, and doubling time is usually constant for exponential functions. So after another day, it should be around 80%. No, wait a minute. Sorry, I had to pause and think about that for a second. That would not necessarily apply in this case because this is not an exponential function. This is what's actually called a logistic function. When you do this one constant divided by a constant plus an exponential, it's called a logistic function. And it kind of looks like this type of thing, and you come up to some upper asymptote, which in this case is probably 1 for 100% saturation of the rumor. Okay, anyway, so for part C, when has 95% of the population heard the rumor? So what we want to do is find out, when does this formula give us 95% or 0.95? So to figure that out, I'm just going to set it equal to it. That is the magic of an equation. You can find out whatever you want to know by setting things equal. So we're going to leave this as a variable that's negative t. And now I want to solve for this t. So t has a bunch of crud surrounding it. Some horrible person put it in an exponent, then they multiplied it by 4, they added 1, and then they jammed it into the denominator of a fraction. I don't know what diabolical maniac could have possibly done this, but I kind of have to like reverse all those steps to get it out of where it's at. So to start with, I'm going to deal with this fraction. Okay, so I'm going to multiply both sides by the denominator. And when I do that, on the left side, I'm going to get this. So I'm just multiplying by exactly what's written in that denominator. And then on the right-hand side, I don't really need to like write it out. I know what I'm going to get is 1, because that was the whole point of multiplying by the denominator, was to just get the numerator because of cancellation. In my mind, I like to think of this as like I just moved the numerator like up here, like with cross multiplication basically. Except on this side it would, you don't have a denominator, but if you did, it would be 1, so you could do a little cross multiplication like that. Okay, anyway, now I need to get the next thing to solve for t is I need to isolate e to the negative t. Right now it's in parentheses, so to deal with that, I'm going to distribute 0.95 to both terms in the parentheses. So this is 0.95 plus 4 times 0.95 times e to the negative t. Okay, and I didn't do anything to the right side. I'm just going to go ahead and multiply 4 times 0.95. If your intermediate steps on the calculator cause you to like round things off, then you might want to avoid plugging in until the very end. But with 0.95 times 4, I don't need to round the answer at all. It's exact. It's 3.8. So I'm okay with doing that. 3.8 e to the negative t. Oh, you know what? I could have actually divided both sides by 0.95 back up here. I didn't think of doing that, but that would have been fine too. In fact, I think when I solved this the other day, I did do it like that. Okay, anyway, now I'm going to subtract 0.95 from both sides. So it's going to be gone from the left side, and then it's going to be subtracted from the right side like this. And I can do that one in my head. That's going to be, it's like $1 minus 95 cents. I'm going to have 0.05 left. And now I'm going to divide both sides by 3.8. Okay, so I have e to the negative t equals, let's see what that number is, 0.05 divided by 3.8, enter. I didn't really like that number. It's kind of, I would have to round it off to write it down. So I think I'm just going to leave the right-hand side as this, which is the exact answer. As a math person, I like to not round things. I want to have all the decimals. I'm very greedy for all those decimals. Okay, so now to get t out of the exponential function here, we need to apply the inverse of the e function, which is natural log. So I'm going to do natural log to both sides, and I like to write it in cursive so that I don't think it looks like 1 to the n, or 1 times n rather. So a lot of times I see students write it in regular printing, and then when they read it back to themselves, they think it's 1n, and then they start doing their algebra wrong, like canceling n's and stuff. But this is the name of a function, just like sine or cosine. You cannot algebra anything with these letters. It's just a name. Okay, so the only thing you can do with ln sort of algebraically is you can cancel it with the e function, like this. And then I'm just going to have negative t on the left. That's the whole point of natural log, is it was made to cancel out the exponential function with base e. And then on the right, I have this, whatever this is. I'll put it in my calculator later. Okay, and then to finish up, I'll just make both sides negative to get the negative off of the left and onto the... Let me scroll up here with my literal paper. To get the negative off of the t, then it goes onto the right side. Okay, so at this point, I need to plug this in and see if it's an answer that actually makes sense. But I like to just do it all in one step without any intermediate rounding, because sometimes intermediate rounding can lead to really bad round-off errors. Okay, so negative ln 0.005, my calculator, divide by 3.8, close parentheses. Got to put parentheses around everything in the ln there. And we get 4.33. 2 or 3 decimal places is fine. Okay, so remember this is supposed to be a time, so this is days, 4.33 days. So I went ahead and boxed it, but you should check this answer. It does kind of make sense though, because time 0, 20% of people heard the rumor at first. By the next day, 40% of people knew it. So 4 days later, I mean, that was pretty fast, right? So 4 days later, 95% of people, yeah, sounds okay to me. We should go back and just quickly check this though. Since we solved an equation, you should always check your results whenever you're solving equations. It's possible to get extra answers that are incorrect even without making mistakes. Sometimes the solution technique itself introduces wrong answers. So we're going to check, does P of 4.33 really equal 0.95? So P of 4.33 would be 1 over 1 plus 4 times e to the negative 4.33. So let's just go ahead and put that in the calculator over here. So 1 divide by parentheses 1 plus 4 times second e negative 4.33. And I'll come down from the exponent, close parentheses. Yeah, that's almost 95%. So that's 0.944997. That's very close. Oh, I put an extra 4 in there, sorry. Okay, that's close enough. And it's not exact because we rounded it to 2 decimal places. All right, let's look at another problem similar to this. This is an investment problem. If $1,000 is invested at a nominal annual rate of 10%, compounded continuously, the investment will be worth A of t equals 1,000 e to the 0.1 t after t years. Okay, so part A and B, we're just going to plug in a couple of times to get a feel for this function, and then part C, we will solve an equation. So part A, it does say that time is in years, and we're asked about 1 year, so I'm just going to plug in 1 for t. So this is going to be A of 1 is 1,000, e to the 0.1 times 1, and I'll just put that in my calculator. Let's see what it is. Where did I stick my calculator? Okay. I don't know if you can hear one of your classmates driving by booming his music loudly enough to make his car doors rattle, but pretty entertaining. Okay, second e, and then 0.1. I don't need to multiply by 1 because that doesn't do anything. Okay, 11:05:17. All right, and whenever you're doing a math problem, you always ask yourself, does this answer make sense? Well, you started with 1,000 and you invested it, and now you have a little bit more. Yeah, okay. If you got like a negative number or less than 1,000 or something, then it's completely crazy, but this seems okay. All right, now after 5 years, we're just doing A of 5. So now I do need to make sure to carry out that little multiplication by 5 in the exponent here when I'm plugging this in. So this is going to be 1,000 times second e point. So on most calculators you would need to put parentheses to protect this multiplication up here, so 0.1 times 5. On this particular calculator, it kind of pops you up into this separate area that's in the exponent that you don't need to protect yourself. Okay, so this will be 16, oops, why did I put an extra decimal? 1648.72. Okay, so our money is continuing to go up, and it went up a lot more because it was a lot longer, 5 years. All right, and lastly, when will the investment have doubled in value? Set up an equation and solve it. So doubled means from when we first invested it. So when will we have 2,000, in other words? So this is my equation. If I want to know when the function equals 2,000, then literally just equal it to 2,000. Okay. So now I'm going to try to solve for t. I'm going to strip away things from starting with things that are the farthest away from t. So that's this 1,000 here. So I'll divide both sides by 1,000 because that was multiplication connecting it there. So divide. So I get 2 on the left, and on the right I have e to the 0.1t. Okay, and now since I've isolated the exponential term on the right, I just need to apply the natural log to cancel out the e function. So the natural log function and the exponential with base e function cancel each other out. So I can bring the exponent down as 0.1t. And now I just need to divide both sides by 0.1. And that should give me t, and I'll just put this in my calculator. ln 2 divide by 0.1, 6.93. And this is just an approximation. Okay, so after 5 years we had 1,648. Could we have 2,000 after almost 7 years? Yeah, seems about right. And of course we should always as well check. So if I do a of 6.93, what do I get? 1,000 times e to the 0.1 times 6.93. See. Oh, do you hear that scratching sound? My cat has come into the room and he is very annoyed about how I'm teaching you guys instead of petting him. Okay, second e 0.1 times 6.93. Okay, so you see we got almost 1,000. It's a little bit more off maybe than some answers because rounding in something that you're going to put into an exponent is particularly is a particularly bad place to round usually. All right, that's it for that problem, and let's do one more. So number 3, if $500 is invested at a nominal annual interest rate of 8%, compounded quarterly, the investment will be worth A of t equals 500 times 1.02 to the 4t after t years. So we're going to start by just plugging in a couple values for t and getting a sense for it. So for a here, we're plugging in 1. So we're getting 500, 1.02 to the 4 times 1. And then I'll go ahead and set up part B here so I can just do both of them on my calculator right quick. So 500 times 1.02, 4 times 2. Okay, and I'll just pop those into this handy dandy calculator here. Times 1.02 raised to the... Now make sure you get the multiplication happening in the exponent and not outside of it. So this is 541 and 22 cents. And the next one, I'm just going to edit what I did before. So, oh no, paws are coming. Oh dear, he's upset with all the papers that I've placed where he usually relaxes on his little cat spot. Okay, so I'm just going to edit this. Wait, can I do it? Yeah, I'm going to try to edit this. There we go. So this will be 4 times 2. Okay, so 585.83. Oh, thank goodness the cat has left after threatening my livelihood here. Okay. And finally, part 3 here, we're going to set up an equation to figure out when will the investment be worth $750. So just take this formula. If you want to know when it's going to equal 750, then set it equal to 750. Okay. And then solve for t, of course. This one will be a little trickier because we don't have e as the base, but we can still do it. So first I'll get rid of this 500 since it's the farthest away from t. So let's see, 750 over 500, I think that'll be a nice number. Let's see, 750 over 500, yeah, 1.5. Okay, so now how do I get 4t down from the exponent of this number on the right? I can still use natural log, even though I don't have e as the base. I just have to go about it a little bit differently. So I'm going to do natural log of both sides. And now I can't just cancel out here because I don't have e on the inside. But what I can do is I can use rules of logs. So rules of logs tell me that when I have something to an exponent inside of any log, I can take the exponent down and place it in front of the log. And that's just because of how when you take the log of something, you're finding an exponent, and you can develop a bunch of interesting rules based on that. This is the power rule of logs. If you forgot what it says, it just says any log of something raised to a power is the same as the power times the log of the base. Okay, so we're going to use that here to say that ln of 1.5 equals 4t times ln of 1.02. Once it's just a single number inside the log, I don't need to write the parentheses around it anymore. And now finally, to isolate t, I'm going to divide both sides by 4 times ln of 1.02. So on the right-hand side, that's just going to leave me with t, and on the left-hand side, this is some big number. Let's find out what number. So ln 1.5 divide by, oops, I forgot my parentheses. Divide by, and now I need parentheses around the bottom to make sure the 4 times ln of 1.02 happens before it gets divided. 1.02, close, close. Okay, 5.12. And this is approximately. All right, so let's ask ourselves if this makes sense. So after 1 year, we had 541. After 2 years, we had 585. And this is saying after 5 years, we're going to have 750. Yeah, I think that's plausible. Of course, we should also check. So a of 5.12 would be 500 times 1.02 times 4, or sorry, raised to 4 times 5.12. So if we plug that into our calculator, let's see, I'm going to do answer we had times 4, enter, and then I'll do 1.02 raised to that answer. There's this little answer button you can actually use on your calculator like that to plug in the previous answer. Okay, and then I'm going to multiply that by 500. Yeah, all right. All right, and that's it for this type of problem, and I'll see you in another video.